Hello, my friends. This is David Heron with TechSparks.com, and what I have to talk to you today about is booting a Raspberry Pi off of a USB drive. So this is applying to both a Raspberry Pi 4 and a Raspberry Pi 400. I have a companion blog post, and the link will be in the show notes. What I want to start with first is a little discussion of why. Because, the Raspberry Pi, normally we just burn an SD card and boot it off of that. And, that's great for experiments. But what if you want to have a longer term running device of some kind? In the case I describe here, I wanted to build a router, a Wi-Fi router, using a Raspberry Pi, and have the Wi-Fi router also serve as a network attached storage, or as other kinds of services, like I have Docker installed on it. The thing about an SD card is that they wear out. And a router is the kind of thing where you put it on the shelf and you let it run for a couple years, and then maybe you might look at it after a couple years, you might whatever, and the SD card will have worn out within a couple years, so that's not really a good idea. What's a good idea instead is to use a data storage that is meant to last for a long time. So that's why I wanted to set up USB booting for a Raspberry Pi. Now, fortunately, the Raspberry Pi Foundation built all the stuff into the boot ROM. It's fairly easy to do. So that's what we're going to do, is to go over how to do it. Okay, the first consideration is power. So there's two kinds of USB devices, I'm sure you're aware. Some are bus powered and some are self-powered. And so if you're using a 2.5-inch laptop drive in an external case, those are usually bus-powered devices. And for instance, in my case, while I've been experimenting with what I can do, I had I've installed Raspberry Pi OS on an SSD. SSDs are low power, but then I tried to attach a regular hard drive, and that ran past the power supply. The Raspberry Pi has a limited amount of power. So if you need to run more than that, then you will need to use a powered hub. That is a USB 3 hub that has its own power supply, and it uses that power supply to power the devices attached to the hub. Another option is to instead use powered devices. So for instance, 3.5-inch drives, those are always self-powered, and they don't draw any power off of the USB bus. You can use as many of those as you want with a Raspberry Pi because they're self-powered. So with those considerations out of the way, let's talk about setting up. To make sure that your Raspberry Pi is correctly configured, it's a good idea to start with Raspberry Pi OS burned to an SD card. So just burn it through the normal means. I have a Raspberry Pi. What's the name of that application? Let me start it up. It's Raspberry Pi Imager. Yeah. I have Raspberry Pi Imager installed, and that simplifies all the stuff because it specifically selects operating systems that run on the Raspberry Pi. You can, of course, use Balena Etcher if you prefer that. And then another thing to do once you have your Raspbian burned onto an SD card is once you have it booted to run sudo apt-get update and sudo apt-get upgrade to make sure that all of your tools are up to date. So then the next step, and this is part of why we needed to have Raspberry Pi OS on a SD card, is to update the boot EEPROM. Okay, so the boot process on the Raspberry Pi has boot firmware installed in an EEPROM, and you can flash that EEPROM using command line tools that are available on Raspberry Pi OS. And as I show here, you type sudo rpi EEPROM update -a. So if I go over here and turn on, so I have a terminal window that's SSH'd into a Raspberry Pi, or actually right now it's not SSH'd into the Raspberry Pi, but if I do that, now I'm into the Raspberry Pi. So if I run that, sudo rpi-eeprom -update -a. Okay, so what the -a means is to automatically update to whatever the latest is. And you see that in my case, it's already updated. If we go back to the browser, okay, you see that when I ran it the first time, it told me there was an update available. Here it says what the current version is and the latest version. And it did the update, and it said updates pending, and I have to do a reboot. So then you do a reboot, and after it's rebooted, you get this where both the current and the latest are the same. And if we go back to my terminal window, that's what's shown here. Okay, so that takes care of making sure everything is up to date. The next thing is about the boot order. So what that means is that there are various configuration settings we can make in the Raspberry Pi, and there's actually documentation on raspberrypi.com that goes over the bootloader configuration. So these are different settings that can be set with the bootloader to customize how it works. And what we're interested in is the boot order. And what that means is the order of which kind of devices it can boot from. So it will try device A, and then device B, and then device C, and then loop back to device A. And the first one that it can boot from, it will boot from that. And you can see in this table there's several mechanisms. It can boot over a network or an RPI boot server or HTTP. If you have a Compute Module 4, you can boot off of NVMe, and so on. So the way this works is you have this table shows a digit. So a digit from hexadecimal 0 up to hexadecimal F. And if we go back to my example, you see that I suggested OXF14. So that's 3 digits. And if you go back to the documentation, you see that the digits are read from right to left, and they can be up to 8 digits long. So if you think about that for a minute, each digit is 4 bits because it's a hexadecimal number, and 8 digits of 4 bits is 32 bits. So that means somewhere there's a 32-bit register or number or something that is holding this boot order value. So I said OXF14. The digits are read from right to left, so that means the first one that's consulted is this USB MSD, which stands for USB Mass Storage Boot, which is what it sounds like. It's booting off of a USB drive. And so that means I've configured it to first check for a USB device, and then OX1 is the SD card, so next it will try the SD card if there's no boot USB device. And then the last is OXF, which down at the bottom of the table, which I have to scroll here, OXF is restart. Okay, so the restart means that it will loop back, so if there's no USB device and there's no SD card, then it'll loop back to the USB device, and it'll keep doing that until one or the other has a boot device. And then here is a table of examples. Okay, so how do we set this? So first off, we run RPI EEPROM-config, RPI-EEPROM-config, and you see that mine is configured as it's shown on the screen capture I did before. And then if you want to edit it, you're going to run sudo -e RPI EEPROM config and then --edit. And so then that launches an editor program. For some reason it defaults to Nano. And then you can change the text of the EEPROM configuration. And then once you write that out, it will modify it, and then I'm sure you need to reboot because you need to test whether the change was done. Okay, so one thing that will happen after rebooting, one test is to make sure there's no SD card and no USB device, and then you should get the Raspberry Pi screen will look like this. And in this mode, it's waiting for one or the other. Right now it says progress trying to boot USB MSD, meaning the mass storage device. So, and then if you insert an SD card, it'll go ahead and boot off the SD card. But let's talk about burning Raspberry Pi OS to a USB device. So, normally we use Raspberry Pi Imager or Balena Etcher to burn to an SD card, but here we're burning to a USB drive, and it's simple. You simply select the device that you're going to burn to, and you can easily select to a USB drive just as well as anything else. You just have to be careful when you're selecting to make sure you're not accidentally overriding your main drive. So you've been warned, don't select your main drive. That would be really bad. So on the first button, you select the operating system, and then on the second button, you choose the storage device. So when you choose the storage device, there's a window like this that comes up, and it lists possible storage devices. And in this case, I had I took this of a screen capture of a device that was a drive that I'd pulled out of a Mac, and it had Ubuntu installed on it or something. So, but whatever, you're gonna, whatever you have attached will show up in this window, and then you select, making sure to select the correct one. And then once you do that, it'll burn. Another thing to mention is that this gear icon right here, you can use that to launch a window that customizes the Raspberry Pi OS that's installed there. But in my testing of that, it didn't seem to do much, so that might not be worth playing with. So in any case, once you've burned Raspberry Pi OS to a USB drive, then you attach it to your Raspberry Pi. And of course, with the Raspberry Pi 4, we have USB 3 ports that are available. So there's 2 USB 3 ports that are available. USB 3 is a lot faster than USB 2. So that means your system will be a lot faster if you are using the USB 3 port to mount the USB device. Now, sometimes when you boot, this screen will show up. It doesn't always show up, but it shows up sometimes, and it has a lot of details about what it's finding. Like in this case, it says no SD card detected, and that the current boot form is the USB MSD, or mass storage device, and it's talking about which partition it's looking for, and so on. So there's a lot of details here. There was one case when I was trying to install OpenWRT on a USB drive, and I'd had the USB drive improperly formatted. So that means I had the USB drive installed, but it wasn't formatted correctly. And I was eventually able to determine that by carefully looking at the information here. So, if you're having problems, carefully look at this and try to puzzle out what it means. And then once you have it booted, okay, if I do that, same command, df-h. Okay, so what this means is /dev/sda1 is the /boot partition. And so that's all the Raspberry Pi boot up stuff. You normally don't look in that directory. The dev root is normally where you're looking. Okay, so for some reason that doesn't exist. I don't know. Anyway, I was hoping that was a symbolic link, but dev root is actually /dev/sda2. And you may be aware that the device name SDA, so that means first off that the USB devices, they act like an old school SCSI device. So that's SCSI disk A, and then the partition 1. SCSI disk A, partition 2, and so on. So that's why that shows up as /dev/sda1. And if it was showing us this for the root partition, then it would be /dev/sda2. All right, and then you see the size, 420 gigabytes of free space. That's because this is a 480 gigabyte SSD. And I haven't put much on it yet. So that's the idea. I've also configured this so directories on this drive are exported with Samba and so on. And I've got a separate article that discusses that configuration. So now if we go back to the browser, the summary is that this is a fairly easy thing to do. Okay, so you'll get much more performance by using a USB drive than an SD card. And it will be especially true if it's an SSD. Because SSDs are much faster than the SD card, etc. Depending on what you're trying to do, you may need a USB 3 powered USB 3 hub, but we talked about that earlier. So this is the system that I have set up. Over here is a Raspberry Pi 4 that's in a Flirk case. These are very nice because the case itself is a heatsink. It works really well. You don't need a fan, and it keeps it really cool. The cable at the bottom is a micro HDMI to full-size HDMI. And then the other thing is the SSD drive that's in an external case. And then, think about how small this is and how easy it would be to carry this with you on a trip or in your backpack or whatever. And you would be able to have a portable NAS that you could just whip out if you're in a coffee shop or whatever, right? Or if you're staying in a hotel and you need to use the local Wi-Fi. Those are things that you could do with this. And I've got a separate article that goes over that. So in any case, I hope this has been interesting and useful to you, and thank you for watching.